Let's continue our this lecture series on NEET PYQ. Today our next chapter is work power energy. Let's start with the first question of work power energy. Question says, if a vector A equals to cos omega ti plus sin omega tj and B is equals to cos omega ti plus sin omega t by 2j are functions of time, then the value of t at which they are orthogonal to each other. Now orthogonal has different meanings. Orthogonal means same as perpendicular, okay? Or you can say orthogonal simply means normal. Okay, any two vectors which are orthogonal to each other, are normal to each other or perpendicular to each other, right? And if two vectors are perpendicular or normal to each other, what do? We find the dot product. The dot product must be 0, right? So for this first one, A vector, let me write here A is equals to cos omega t I cap plus sin omega t j cap, right? And our B vector is equals to cos omega t by 2 I cap plus sin omega t by 2 j cap. Now A dot B here must be equals to 0, correct? If A dot B is 0, let's substitute it over here. Cos omega t I cap sin omega t j cap dot product with cos omega t by 2 I cap sin omega t by 2 j cap, correct? Now, how do we do the dot product? Now, you must be thinking, sir, you started work power energy, then why first question is from vectors, okay? Initially, the first topic is dot product. We are covering topic wise, right? So, let's see this dot product. I will be multiplied with I using dot product. It will give you what? Cos omega t into cos omega t by 2 plus sin omega t into sin omega t by 2, right? In dot product, we multiply I with I and j with j. What is I dot I? It's 1. What's j dot j? It's 1, right? Now, this must be equal to 0. Now, sir, from where you got this 0? As per the question, it is orthogonal. Or instead of orthogonal, if it is written perpendicular or normal, you will do the same thing. You will put the dot product as 0, right? Now, on the right hand side, if you look carefully, it is cos A, cos B plus sin A, sin B. Now, what is the formula for cos A, cos B plus sin A, sin B? Let me write the identity for you here. So, cos A, cos B plus sin A sin B is nothing but cos A minus B, correct? I hope this is clear, right? So let's substitute here. A is omega t and B is omega t by 2. So this will be cos omega t minus omega t by 2, correct? On the left hand side, what is 0? So cos 90 degree is 0. So cos pi by 2 is 0. Let's cancel out this cos with cos, you can say. And what you left with? If cos 90 is equal to cos this thing, then 90 must be equal to this. So pi by 2 is equals to omega t minus omega t by 2. Correct? And this will give us here what? It will give us pi by 2 equals to how much? Omega t by 2. Correct? Sir, how you got omega t by 2? Cross multiply. Okay. Now 2 cancels with 2 and you left with t is equals to pi by omega. Correct? So our correct answer is t equals to pi by omega, option A. Clear? Let's see the next question. Great. Again another problem. Here straight away instead of saying orthogonal, they have said perpendicular. So if two vectors are perpendicular, the dot product must be 0, right? So let's find the dot product here. So A here is, I am taking the first vector as A vector 2i plus 3j plus 8k. And another vector B is equals to 4i minus 4j plus alpha k. Now let's find here A dot B. Finding A dot B, 2 4s are 8, 3 into 4, be very careful, I will be multiplied with I, j with j and k with k. So 3 4s are minus 12 and plus 8 alpha, correct? This we do in dot product. Be careful, cross product we will see in the next chapter. So here this dot product has to be what? 0 because it's perpendicular, right? So 8 minus 12 minus 4 plus 8 alpha. Let's take this minus 4 that side. So 4 equals to 8 alpha and alpha will be equals to 1 by 2. 4 by 8 is 1 by 2. Clear it is? Is there any option? Yes, option A is correct. Okay. Let's see the question number 3. The vector sum of two forces is perpendicular to their vector difference in that case. Okay. Then what is the condition here which is true? So vector sum of two forces, which is magnitude of F1 plus F2 and difference F1 minus F2. They both are perpendicular. These vector sum and vector difference is perpendicular. So which means that dot product has to be 0. Let me repeat again. If two vectors are perpendicular, their dot product has to be 0. Clear? So here it will be giving you f1 square minus f2 square will be 0, or magnitude of f1 has to be equal to magnitude of f2. Clear? So which is correct option? Option B. So they are equal to each other in magnitude. I hope you understood this. Okay. Let's see the next question. Great. Our next problem says a position vector of a particle r. Now r here is nothing but a cos omega t I cap plus a sin omega t j cap. Correct? The velocity of the particle. You have to find the velocity. Now v is nothing but the derivative of position dr by dt. Let's differentiate it. A is a constant taken out. Derivative of cos, sir, minus sin omega t. And derivative of omega by chain rule, omega t, it's omega I cap. Here, this is A outside. Derivative of sin, sir, it is cos omega t. And derivative of omega t, sir, omega j cap. This is the velocity. Now, if this is our velocity vector, which one of these is true? The first one, it is directed towards the origin? No. Is it directed away from the origin? Okay. That we have to see, not sure. Parallel to the position vector. Now parallel is the velocity vector is parallel to the position vector. For parallel and perpendicular, we have a direct way to check, that is using dot product. So if we find the dot product of v and r, if it is reduces to 0, if v dot r, if the dot product of any two vectors is 0, then in that case it is perpendicular. Clear? So let's find the dot product here. So here when you multiply this with this using dot product, a and a, sir, a square, omega, sir, not there, cos omega t and sin omega t. So I am putting here negative cos omega t and sin omega t. I dot I is 1, correct? And here a and a, this is a square plus omega is only omega, sin and cos, sin omega t, cos omega t, or cos omega t, sin omega t. Now look at this very carefully. This whole thing cancels with this because there is a negative sign in front here. Clear? And it reduces to 0, which means both are perpendicular to each other. So velocity vector is perpendicular to the position vector in this case. Let's see the next one. Great. Question says the angle between the two vectors. How do we find angle between the two vectors? Using dot product itself. And what is our formula? Cos theta is equals to a dot b whole divided by magnitude of a, magnitude of b. Correct? And what is our a dot b? Sir, a dot b will be 3i plus 4j plus 5k magnitude, sorry, dot product with 3i plus 4j minus 5k whole divided by magnitude of this, which is 9 plus 16 plus 25, and here also 9 plus 16 plus 25, correct? Now using the dot product, it will be 3 into 3 9, 4 4s are 16, j with j and k with k, so minus 25. Now look at the numerator itself is becoming 0, what, regardless of the denominator. 9 plus 16 is 25, 25 minus 25 is 0. Cos theta is 0. For what angle cos theta is 0? Be very careful, it is 90 degrees. So option A is correct in this case. Clear? For what angle cos theta is 0? 90 degrees. So both the vectors are perpendicular to each other, right? Let's see the next question. Great. Our next question says the kinetic energies of two similar cars A and B. So let's say this is our kinetic energy of A. Let's say this is our kinetic energy of B. A is 100 joules and B is 225 joules. I hope this is clear. Okay. On applying brakes, car A stops after 1000 meters. So 1000 meter is the stopping distance for the first car. And car B stops after 1500 meters. So SB distance is 1500. Fine. If FA and FB are the forces applied by the brakes on car A and B, then the ratio of the forces. Clear? Now question is saying that the kinetic energy of the first car is this much and it is stopping. When you apply brakes, it stops after 1000 meters. Similarly, kinetic energy of the second car is this much and you are applying brakes and it stops after 1500 meters. Question is, how much is the ratio of the forces which you are applying to stop the cars, right? Okay. So we know from our simple concept, work energy theorem, the amount of work you are doing on any system is changing its kinetic energy, right? So what is our work done? So work done will be force into displacement. and that changes the kinetic energy. So it is stopping means final velocity 0. So straight away kinetic energy of, so let me write here, Fa is the force acting on the first car. Displacement of the first car will be responsible for kinetic energy of the first car. Clear? Similarly, force for the second car, displacement of the second car and kinetic energy of the second car. Let's divide both of them and figure out our value for ratio of forces. So Fa, displacement of A, kinetic energy of A, whole divided by force of B, displacement of B and kinetic energy of B. Let's cross multiply. So Fa upon Fb, and I am taking this on the other side. So Sb will go up. Let's substitute now values. Kinetic energy of A 100 joules, kinetic energy of B 225 joules, Sb goes up 1500, Sa goes down 1000, right? So let's this with this with this. Okay. Now let's cancel out 5. Okay. 300s, 5 2s, okay, 2 15s, okay. Now again 5 30s, 5 45s, 5 6s, 5 9s, 3 2s and 3 3s. So ratio will be 2:3. Is there any such option? Yeah, option D is correct in this particular problem. I hope you understood. Very simple, straightforward question on the work energy theorem. Let's see the next question. Great. Our next problem says an object moving along horizontal x direction with kinetic energy. What's the kinetic energy of the particle? 10 joules. Great. Is displaced through this much. So displacement of the particle 3I cap by the force F is equals to how much? Minus 2I plus 3J. Okay, fine. The kinetic energy of the object at the end of the displacement, right? Now be very careful. We'll again use work energy theorem. What does our work energy theorem says? It says amount of work you are doing on any system is changing its kinetic energy, which means force into displacement is nothing but final kinetic energy minus initial kinetic energy. Okay. Now final they are asking, initial we already have, so kinetic energy final will be equals to force into displacement plus kinetic energy initial. I hope this is clear. I took this on the left hand side. Now let's substitute the values. We are looking for this one. Force is nothing but minus 2I plus 3J. Let me confirm it from the problem. Minus 2I plus 3J. Displacement is 3I. So here let me write here 3I. And what's the initial kinetic energy? Initial kinetic energy is 10 joules. So let's do the dot product here. J, there is no J here in the displacement, so it will be removed. 3 2s are minus 6, okay, plus 10, correct? So this will be 4 joule. Let's see if there is any option. Yes, 4 joules is there already in the problem. So our correct answer is 4 joules. I hope you understood this concept. Let's see the next one. Okay, a beautiful problem. Okay, very interesting problem. Let's read the question. It says, consider a drop of rain. So let's consider, let's assume this is a drop of rain. Okay, having a mass of 1 gram. So mass of this raindrop is 1 into 10 to the power minus 3 kg. Raindrop has mass of 10 to the power minus 3 kg. From a height of 1 kilometer, h is nothing but 1 kilometer, 1 into 10 to the power 3 meter, right? It hits the ground with the speed v is 50 meter per second. I hope this is clear. Okay, fine. Take g as constant. The value of g is nothing but 10 meter per second square. Acceleration due to gravity. The work done by gravitational force and the resistive force of the air, right? We have to find both of them. First, let's find the work done by gravitational force. Now, let me remind you, because these lectures are revision, right? So, you have already done gravitation chapter. Now, from gravitation chapter, what you have learned? You have learned that the work done by gravitational force is nothing but the potential energy stored in this drop, and that will be nothing but mgh. Okay, let me write here. It is work done by gravity. Okay, wg. Because we have to do the second part also, we'll do that side. So here work done by the gravity will be equals to mgh. What is the mass of the drop? Sir, 10 to the power minus 3. What's the acceleration due to gravity? Sir, 10. And what's the height from which it is falling down? It's 10 to the power 3. So this will be 10 joules, right? 10 to the power minus 3 plus 3 cancels out and only 10 joules left. This is the work done by the gravity to get it down. Okay. Now they are saying what is the work done by resistive force of the air, right? Now there are two work which are done. One is gravity downward, another one is upward. Now no need of going into force, otherwise you will need directions, right? We can use simple our work energy theorem. It says that the total work done here by the gravity as well as the resistive force will do what? It will change the kinetic energy of this drop. Okay. we have already the velocity with which it is falling down, right, at the end. So that is 50 meter per second. So work done by the resistive force will be kinetic energy of the drop minus work done by gravity. Now what is the kinetic energy of the drop? It will be half m. What's the mass? 10 to the power minus 3. What's the velocity? 50 into 50 minus what's the work done by gravity? That's 10. So this we can simplify it further. This will be 5 5 is 25, 25 by 2 and 2 zeros I am cancelling. It will be into 10 to the power minus 1 minus 10. So that will become 2.5 whole divided by 2 minus 10. That's 1.25 minus 10 and that's minus 8.75 joules. Now be very careful. Many students will think, sir, we already had the first answer, right? The first answer is 10 joules. Then straight away you can see option C is there in which there is a plus 10 joule. Okay, why you did the other part? Be very careful, understand the concept, because these times, okay, the questions which are formatted, they are according to concept based. Okay, so if they'll directly ask you this thing, then otherwise, so be very careful to figure out both of them, right? Let's see the next one. So our next question says a particle of mass 10 grams, so m is nothing but 10 into 10 to the power minus 3 kgs, right, moves along a circle of radius r is 6.4 into 10 to the power minus 2 meters with a constant tangential acceleration. Okay, so if this is a circular motion, inward acceleration is known as centripetal acceleration and this acceleration is our tangential acceleration, right? So they are looking for the tangential acceleration. The question is, what is the magnitude of this acceleration if the kinetic energy? Now kinetic energy I am writing Ke, which is equals to how much? It is equals to 8 into 10 to the power minus 4 joules. Okay, they are looking for A and they have given the kinetic energy at the end of second revolution. Be very careful, this is quite important, at the end of second revolution. So two rotations are already done, right? Let's come back to the problem. So kinetic energy will be written as half mv square, that will be equals to 8 into 10 to the power minus 4 joules, right? So we can write here v square is nothing but 8 into 10 to the power minus 4, and let's take this 2 on that side. It will be 2 whole divided by the mass of the particle. What is the mass of the particle? 10 into 10 to the power minus 3, correct? Now that will give us 16 into 10 to the power minus 2. Okay, that's our v square. Why? 10 into 10 to the power minus 3 becomes 10 to the power minus 2, and this minus 2 goes up and 10 to the power minus 4 becomes minus 2, right? And 2 into 8, it becomes 16. That's our v square. Okay, I hope this is clear up till here. Now since they are asking our tangential acceleration, we will make use of our equation of motion straight away. V square minus u square equal to 2as, right? And here u square is 0, v square is already given 16 into 10 to the power minus 2. Sir, why u square is 0? Because at the beginning, they said from the beginning, right? Revolution after the beginning. So beginning means u is 0, initial velocity was 0. So it will be 2, A we are looking for, and distance. Now you have to be a little careful with this distance now. At the end of second rotation, each rotation is of 2 pi r because it's a circular motion. So 2 rotations means 2 times 2 pi r. What's the value of r? R is given here as 6.4 into 10 to the power minus 2. I hope this is clear. Let's solve it here, remaining one. So A will be equals to, let's take everything on the other side. It will be 16 into 10 to the power minus 2 on the top, and below this 2 2s are 4 2s are 8. Pi is 3.14. Okay, let me write it here again, 3.14, and this is 6.4 into 10 to the power minus 2. 10 to the power minus 2 gets cancelled with 10 to the power minus 2. 8 2s are 16 and 2 3.2s are, okay. So you left with A as nearly 1 upon 3.14 into 3.2, correct? 3 3s are 9 straight away, but if you nearly take it as 9, as because there is 1.414 also and here 2 also, so nearly approximately I am just taking it as 10. So A will be equals to, nearly equals to, not equal to 1 by 10. Now 1 by 10 is nothing but nearly equal to 0.1 meter per second square, correct? So correct answer is 0.1 meter per second square, option C. Let's see the next question. Great. Our next question says a particle moves from a point. So let's say the initial point A is nothing but minus 2i plus 5j. This is our initial point of the particle, to another point. The final point it is going to be, which is equals to 4j plus 3k. Great. Okay, fine. When a force of, so force value here is given as 4i plus 3j Newton is applied. How much work is done? Very simple, straightforward question. Work done is nothing but the dot product of force into displacement. Now many students, those who have not done practice, okay, they do remember this formula, but they get confused with this, sir, should we take A or should we take B? See, clearly it is given that this is displacement, right? So if you are finding displacement, you have to subtract both, okay, because then only you will get the displacement vector. So displacement vector is nothing but final position minus the initial position B minus A. Be very careful. When you are going from A to B, it will be B minus A. When you are going from B to A, it will be A minus B. So straight away we will apply that concept. So this will be 4 plus 2, 6 j cap. Oh, sorry, wait. Here it is j and there it is I. So you have to be very careful when you are subtracting. Here there is no I. So it will become 2I, positive 2I, and 4j minus 5 minus j cap. Great. And 3k minus 0, it will be 3k. Let me repeat again. Since there is no I, you can subtract I with I, j with j, and k with k. You can add I with I, j with j, and k with k. Clear it is? So here, since we are subtracting both, there is no I here. 0 minus minus 2, this will become this. Okay, you can try this yourself. So f is equals to 4I plus 3j, right? That's our force acting on it. Let's make the dot product here. So this will be 2I minus j plus 3k. Let me repeat again. We have done already many problems. Let me remind you again. When you are multiplying using dot product, again I with I, j with j, k with k. Sir, but there is no k here in the first part. So 0 we will take, and that will be multiplied to give it 0. 4 2s are 8. 3 into 1 minus 3. So this will give you 5 joules of work is done in this case. Option C is correct. Understood? So be very careful. Work done is a scalar quantity. No I, no j, no k. Let me come back to the next question. Great. Our next question quite similar to the previous one. A uniform force F is equals to how much is given? 3I plus j. Again a vector quantity. Okay. Newton acts on a particle of mass 2 kg. M is nothing but 2 kg. Let's see if we require mass here in this case. Hence the particle is displaced from the position. So initial position A is 2I plus k. Be very careful. I don't have j. So just to keep it easy, I am making it 0j plus k. Correct? Okay, so can we write 0? Yeah, doesn't make any difference. To position B, what's our position B? Our position B is equals to 4I plus 3j minus k cap, right? Now, when you are going from A to B, okay, what will be your displacement vector? Sir, our displacement vector will be AB, that will be I minus I, that will be 2I, j minus j, which is 3j, and k minus k, that will be minus 2k. Let me repeat again. 4 minus 2 is 2, 3 minus 0 is 0, and minus 2k. Okay, this is our displacement vector because we are going from A to B, right? Now, what will be your work done? Our work done will be force into displacement AB, correct? Let's find the dot product here. So, force here is 3I plus j, and displacement here will be 2I plus 3j minus 2k. I hope this is clear. Let's multiply both. So, it will be 3 2s are 6. And j multiplied with j, it will be 3. It will be 9 joules of work is done in this case. Option C is correct here. Clear? Because there is no k, it will be 0. I hope you are getting it. Let's move to the next question. Okay, so our next question is a body is moves a distance. Our distance here is 10 meter. Okay, fine. Along a straight line. So along a straight line, it is moving under the action of 5 Newton force. So F is equals to 5 Newton. Okay, fine. If a work done is 25 joules, so work done here is 25 joules, okay, then the angle between the force and the direction of the motion of the body, right? So it will be, if it is moving in a straight line, here this is the displacement itself. So work done will be equals to force into displacement into cos of angle theta, right? We know this, okay? So when do we use this formula? If the magnitudes are given and the angle between them is given, right? The previous formula, we had a dot product. Here we don't have a dot product. This is a product, straight away scalar product, right? For f dot s cos theta, or you can say it in another way, sir, this is the same thing what you call it as dot product, that f dot s in vectors is equals to magnitude of f, magnitude of s cos theta. You can say it like this also, okay? Same thing it is, right? Okay. In the previous problem, we used this expression. Now we are using this expression in this particular problem when we are given with the magnitudes, right? Okay. So this dot doesn't mean dot product in this case, right? It simply means multiplication. Okay, fine. Let's substitute. Work done is 25. Force is 10. Displacement or distance is, oh sorry, force is 5 and displacement is 10. Cos of angle theta. Let's take this 50 on the other side. It will be 25 by 50. That's equals to cos of angle theta, right? Now 1 by 2, that's cos theta. For what angle cos theta is half? So theta being 60 degree, right? So our correct answer is 60 degree. I hope this is clear. Okay. Yeah. Let's see the next question. Great. Our next question says a body constrained to move in y direction. Constrained means restricted to move in y direction is subjected to a force given by F is equals to how much? F is given as minus 2I plus 15J plus 6K, right? This is the force acting on it. Okay, fine. The work done by this force in moving the body through a distance of 10 J cap meters along y axis. So displacement is 10 J cap. Very simple, straightforward question. If you are multiplying this, you have to now use dot product. Force into displacement dot product. When you multiply, this will be, can I multiply I with j? No. Can I multiply k with j? No. I can multiply j with j. So 15 into 10, 150 joules. Straight away, no j cap. Why? Because it's a scalar quantity. So 150 joules, option A is correct. Understood? Let's see the next question. Okay, theoretical problem. When a body moves with a constant speed along a circle, if it is a moving with a constant speed, no work is done. Be very careful. Here the correct answer is no work is done on it. Okay, when it is moving with a constant velocity. Okay, constant speed, sorry. A particle of mass 5m. Okay, so initially the particle is there with a mass 5m. Okay, at rest, so initial speed is 0. Suddenly breaks into its own 3 fragments. So 3 fragments it is breaking into 1, 2, 3. Okay, fine. 2 fragments are of mass m each. So if this is m and this is m, this is obvious by law of conservation of mass, m, 2m, and here it is 5m. So this will be 3m. I hope this is clear. Okay. Moving mutually perpendicular to each other. So if it is moving along x-axis, this is moving along y-axis, right? Mutually perpendicular to each other with a speed v each. So let's say this is speed is v and this is also speed v. Okay, fine. The energy released during this process will be how much? Clear? So we have to find the total energy release. Okay. So let's understand here. We will make use of a concept which we learned in the previous chapter. In case if you have not watched the previous chapter PYQs, the link is in the description. You can watch it, right? So, and if you have any suggestion, you can give it. Let's come back to this one. So here we can see that the momentum, okay, momentum by law of conservation of momentum, the initial momentum is, so let me write it here only. Okay, fine. Pi is equals to Pf. Okay, law initial net momentum must be equals to the final momentum of the system. So final here mvi cap, mvj cap. We have done one problem, in fact more than one problem on such type of problem. This is I and this is j. Be very careful. Momentum is a vector quantity. So vector quantity I cap j cap, very important. And here the third one, we don't know the velocity. So let me just write it 3mv dash, right? Okay. Let's divide the whole equation with m. So this, and take this v dash on the other side. So dividing the whole equation with m, all the m will go. So vi cap, vj cap, and this is 3. So minus 3. When you take it on this side, it will be minus 3. I am taking that minus, or let me write it in one more step. I just took this minus 3 v dash on the that left hand side and I left with this. Okay, I'm just keeping it like this. Okay, now let's take this minus 3 that side. It will be v dash will be equal to minus v by 3 I cap minus v by 3 j cap, right? So what will be the velocity of the third particle? That will be the magnitude of this v dash. V square by 9, v square by 9, 2v square by 9, 2v square by 9. I hope this is clear. Okay, great, understood. So this will be under root v square by 3. This is our final velocity of the, oh sorry, v square, and now, so we can remove this. Okay, now fine. Root 2, v square under root cancels v, and root 9 is 3. Clear? This is our velocity of the third particle. We got all the velocities. Now let's find the total energy. So total energy will be the sum of all these energies. So let me solve it over. Okay, yeah. So total energy will be the sum of total energies half mass of first particle, velocity of the first particle, half mass of second particle, velocity of the second particle. Sir, why didn't you use ij? Be very careful. We are finding energies. It's a scalar quantity and not vector quantity. So we have taken already squares. Okay. What will be the third one? So third one has a mass of 3m. So it will be 3m. And what's the velocity? V square. If you square this, it will give you how much? 2. Root 2 square is 2. V square upon 9. I hope this is clear. Let me repeat again. Root 2 square is 2, v square and 3 square is 9. Clear? Let's take half mv square common from all these expressions. What you left with here? Sir, 1. What you left with here? Sir, 1. And half mv square. What you left with here? 3 and 3. 2 by 3. Be very careful with this. I hope this is clear up till here. Okay. Half mv square, taking common 1. If you have any confusion, half mv square into 1, half mv square, half mv square into 1, half mv square, and half mv square into this whole thing, you will get same thing. Okay. So how you got 2 by 3 here? See, half m and v square I have taken out. So you left with 3 to the 6 upon 9. 6 upon 9 is nothing but 2 by 3. Clear? Now this on solving, this will give us half mv square, and that will be 3 to the 6 plus 2, 8 by 3. So that will be 4 by 3 mv square. That's the total energy. Is there any option 4 by 3 mv square? Yes, option D is correct for this particular problem. Okay. We'll continue with this in our next lecture. Okay.